Continue. Got it. Okay, good morning, everybody. Welcome back to our big data again, we're on our topic 7 over here in our GitHub repository covering transactions. And if you haven't realized it yet, the transactions are very difficult. Again, concurrency, famously like the most difficult problem in computer science. And transactions is our technique in databases for handling concurrency. And so we've been talking about last week about the different guarantees that the database provides for us with transactions, that I might not have used this actual acronym yet about the ACID guarantees. I'll come down here. Right now, the ACID guarantees is a common acronym used in databases, talking about the guarantees of transactions. We have definitely said the words like atomic and consistent and isolation, that the transactions give us all of these features. Another cool one that we get from transactions and databases in general is this idea of durability. Durability means that the committed data is saved to the system in a way so that even if there's like a catastrophic failure, like X-rays hit the database and flip a whole bunch of bits, or somebody comes up with a hammer and smashes things, your data is still going to be saved. So very strong guarantees about data safety there. The atomicity, again, with our transactions, that if something gets added to the database in a transaction, everything gets added. So it's either all or nothing. The consistency, whatever sort of constraints that we have, whether it's like these unique constraints or these foreign key constraints that we saw in one of our previous labs on the banking transactions, or whether it's one of these like application-specific constraints that we've defined using our own custom locks, like we saw this past week. The database is going to guarantee for us that consistency. And then the isolation on transaction, we've talked about in your quiz that's coming up, these different transaction isolation levels and how that affects things. And so lots of very complicated things working together here on these transactions. Today in class, we're going to finish talking about this topic 7 transactions, finish talking about your quiz material, and next class period, Thursday, we will have our actual quiz. Handout-wise, we're going to go over this quiz notes.pdf, finish going over that today. I'm going to refresh my screen here for a second because there's also now in this folder a quiz notes2.pdf file. There's no new material in this quiz notes2.pdf file. There's no new material inside of this, but there is a lot more practice problems. I was realizing this morning that we're likely in class today to cover many problems, and I just wanted to make sure that you all had more problems to be able to practice for the quiz on Thursday. So up front, there's another handout. We're not going to probably look at any of the problems in that handout today, but it's just another set of practice problems for you to work on. There's also, besides these quiz notes files, this quiz example. This is a version of the quiz from last semester, so you can see exactly like what types of problems are going to be on the quiz. Again, the formats, let's go over the rules again really quick for the quiz. In order to do that, I'll go over here to my other screen and scroll up to the top of this quiz practice problems where it has the instructions over here. And the main thing of interest rules-wise is that you will be allowed to use a computer on the quiz. You will be allowed to access the internet. If you would like to use, for example, ChatGPT, you're welcome to do so, although I suspect it will give you, it is not the best tool to use for something like this. The main thing that I think will be useful on the internet is the documentation for Postgres. So coming down again into our topic 7 transactions in the lecture notes sections, scrolling down a little bit more to the quiz details section, and then down here there are these 4 links to the documentation and these 3 links down here to tutorials. These are the things that I expect will be useful for you on the quiz on Thursday. And again, I recommended that before today, before this week in class, you had read through these links here. If you haven't done that yet, that's okay, but definitely recommend you do that before Thursday. Again, we're not going to be able to cover everything in class, all of the different weird possible edge cases that can come up, but these links do in fact cover all of those things, and you'll want to, at the very least, make sure that you know how to navigate these links for the quiz on Thursday. Again, points-wise for the quiz, because this is such an important topic and also a difficult topic, one that I want to make sure that you all are spending a sufficient amount of time preparing for. We did not have a homework due today so that you would have time to prepare for this quiz. And the quiz is going to be worth double the amount of points, worth 16 points instead of the standard 8 points that our previous quizzes have been. Any questions about anything administrative? Yes. Great question. The question is, will there still be 4 questions on the quiz? And the answer is that, so last semester when I did this, there were 4 questions on the quiz. I've been telling people who've asked this that there will be 4 questions on the quiz. So if we take a look here at this quiz example.pdf for a second, again, this is the last semester's version of this quiz. There's a lot of, or there are exactly 4 problems, and they're all relatively long problems. So I've been rethinking this and thinking that I'll probably make it a little bit more than 4 questions, certainly less than 8, somewhere between 4 and 8 inclusive. But if there are more than 4 questions, then it will be like easy sort of questions from the beginning of the notes packet. And I think if there are more than 4 questions, it'll be done in a way where it's beneficial to you all in terms of getting like partial credit, basically splitting up a hard problem into 2 easier problems. So expect worst case 4 problems, 4 hard problems, best case 8 easy problems, probably somewhere in between. Good question. Any other questions on anything administrative at this point? Okay. Oh, yes. If I go to this?
No, you gave us like 4, but then below that there are also
Yes. So the question is, there are 7 links total here in this README file, 4 that go to the documentation, and these are intended to be references, that they contain all of the information that you need for the quiz, need to know, and there's short explanations here about which sections in these links you are responsible for and which you are not responsible for. And then there are 3 tutorials down here. And the tutorials, again, are easier to learn from, but much larger. And the question is reading these 3 tutorials enough, or do you have to read everything? And the answer is that I honestly haven't even read through all 3 of these tutorials in full detail, so I can't say for sure whether these are enough or not. These links up here, these are sort of like the gold standard of what is enough. But really the only purpose of these 3 links down here, the way you should think about it, is that the 4 links up above, potentially like very difficult to understand because it's very terse. Again, Postgres documentation is very famous for being among the best documentation in any project anywhere in the world. But it is definitely designed for people who already understand what's going on, and it's designed to like help jog people's memory or to highlight differences maybe between one database and another, and is not a tutorial for getting somebody up to speed on things from like ground zero from nothing. And so these links down here, more tutorial oriented, more like if the explanations up above here not making sense, too terse, not enough examples maybe, then the explanations down here expand on that, but they might not cover everything up here. The things up here are the gold standard of the thing that you have to know, and the links down below are just optional helper links to help you understand the things above. Did that answer your question, Avizer? Okay, great question. Any other questions? Okay. Then I will switch my terminal back over here, and we will pick up where we left off in our quiznotes.pdf file. And we will finish today again everything that you need for your quiz on Thursday. Again, there is a quiznotes2.pdf file which does not have new material inside of it, but it has more example problems related to edge cases that maybe were not fully explored in this notes here, or things that we might talk about today, but then as we work through an example problem in these notes, there's not any more example problems for you to work through on your own, and I've moved those into the quiznotes2.pdf. And there's a handout up here if you'd like a physical copy. Otherwise, it's quiznotes2.pdf in the GitHub repo. We've worked our way through most of this file so far, and I think last time we ended on this row-level locks section, that everything we've talked about so far in terms of locking has been on the table-level locks. You saw, we very briefly introduced these row-level locks, some of the intuition behind it last lecture period, last Thursday. And then in the lab last week, you saw some maybe motivation for these row-level locks, that they're a way for us to maintain isolation while allowing a little bit more parallelism potentially than the table-level locks. And so we'll start off today, again, problem 33 here, where we left off last time. We'll redo this problem in a little bit more detail, going beyond just the intuition, and actually seeing how the documentation lets us predict things here. So on the right-hand side, I have my two terminal windows open. Again, anytime you are working through these problems to prepare for the quiz, I recommend you have two terminal windows open with Postgres side by side, one terminal window being session 1, the other terminal window being session 2. But again, on the quiz itself, you will not be allowed to connect to Postgres. The only reason that you're allowed to have your electronic device for the quiz is to access these links right here in order to be able to predict what Postgres will do. I could print out, I thought about printing out these links for you so that there would be no electronic device at all, but part of the purpose of this class is to give you practice, just like working with the documentation in a real setting. And so I want you to have that actual practice in the quiz of looking through this documentation and finding the appropriate things, and not, I don't know, going through a big printout of stuff. So that's why you're allowed to use your computer, again, to access the internet, but not to access Postgres. When we're practicing the quiz, understanding what's going on, we'll be accessing Postgres. On both of my terminal windows over here, I'm going to open up my pSQL window connecting to Docker. You can see in the top right corner over here, I've already I've run the Docker Compose down. So I need to do Docker Compose up -d, and then Control R, find my pSQL command, connect to pSQL in the top right, Control R in the bottom right, find my pSQL command. And now I'm connected to pSQL in both windows, this top right window and the bottom right window. And now I can step through problem 3. We'll step through it line by line. And again, each line here corresponds to sort of one timestamp. The row numbers here are like time numbers. and you'll always have just one line per session. Or one command per session on each line. On session 1, I've been using the top right corner for session 1 here, so let's start with that. Create table T, a int like that, and then an insert into T values 1, up arrow change 1 to 2, up arrow change 2 to 3, and then in the bottom right corner, session 2, line 5, begin my transaction over here. In the back to session 1, line 6, begin my transaction right here. And now line 7, the first interesting command, this update command, update T set a equals 6 where a equals 1. Update T set a equals 6 where a equals 1, semicolon like this, and hit enter. And now, last time we saw on line 8 that if I were to run line 8, this is going to block, and that's why we've circled this command right here, because it's going to block. And last time we talked about, like, intuitively why it's going to block, that here, line 7, the command that I just run, this is going to affect all the rows where a equals 1. In particular, it's going to affect the row created on line 2 in session 1 right here. And line 8 is also trying to affect that same row. It has the same condition over here where a equals 1. And so line 8, it can only perform its action if or whether it's going to perform this update depends on whether line 7 will get committed or whether it will get aborted. And so intuitively, it makes sense that line 8 has to block here. And that's where we left off last time. What we're going to talk about today is what are the actual locks going under the hood and how can you predict that this is going to block a little bit more formally without relying on just like the intuition that it's affecting the same row, so it must block. Before we do that, are there any questions about where we're at, what the current setup is, or what we're about to do? Okay. So, first thing, every time we're thinking about whether something's going to every time we think about whether something's going to block or not block, we need to think about what are the locks on the table. So I'm going to switch back over here. We have this useful set of commands right here, which tells us about what are the current locks that exist on a table. And I will use this sort of shortcut command to tell us what locks at the table level were created by this update command. So again, on the quiz, you're not going to be able to do this. On the quiz, you'll have to go through the actual documentation, look for the update command, and see that it creates this row exclusive lock on the T table when you run this update command. Just using this command as a shortcut right now to save us a little bit of time so that we can see that it does have a row exclusive lock. And again, the update command on line 8 will also acquire the row exclusive lock. Those two locks will not conflict with each other. Again, back in the documentation to predict that, under the explicit locking, under the table level locks, scrolling down, there's this big, large table right here, which tells us that row exclusive locks do not conflict with row exclusive locks. And so at the table level, these commands will not block from each other. What we're going to talk about now is this row level blocks to explain why these two commands are going to block from each other. Under this section, there's a similar looking table like this, where there are now 4 types of lock modes that can exist only on an individual row and not on the individual table. What's going to happen is that we're going to see that there's this for no key update lock that is created by the update command. And this will affect only the row that is affected by the update command. So on line 7 right here, all the rows that satisfy this condition right here, where a equals 1, all the rows that satisfy this condition are going to have this for no key update lock acquired on them. In order to understand, or in order to figure out, in order to predict that this is going to be the lock that is acquired on the update command, like before, there are descriptions of each of these 4 lock modes right here, and there's an explanation about what commands are going to acquire what lock modes. And here for no key update, we can see that this lock mode is acquired by any update that does not require a for update lock. So the conditions are a little bit more complicated here because you'll have to understand multiple lock modes, read the descriptions here to understand in detail what is the difference between for no key update and for update. In this case, again, we're running an update command. So this is the key sentence for us in the for no key update section. And it says this lock mode is also acquired by any update command that does not acquire a for update lock. So we'll have to determine, are we going to acquire this lock right here or this lock up here for our existing row? In order to understand whether an update command needs the for update lock, we'll look up here, the for update lock mode also acquired by any delete or also acquired by any update that modifies the value of certain columns. Currently, that set of columns considered are those that have a unique index on them that can be used by a foreign key. So unique index, foreign key, those are keywords that make you think you need the for update lock instead of the for no key update lock. In this case, coming back over to the problem set over here, we are updating column A right here. A has no particular constraints on it, does not have the unique keyword, does not have the foreign key keyword anywhere involved in this problem. And so because of that, we know that we will be acquiring this for no key update lock on that row and not the for update lock on that row. That'll be applicable for both line 7 right here, this update right here, line 7, and applicable for line 8 right here. They will both satisfy those same conditions, so both acquiring this for no key update lock. In order to predict whether line 8 is going to block or not block, now we have to come down to this table over here and check, does the for no key update, which we are already acquired on line 7 right here, does for no key update conflict with for no key update? And it turns out that yes, in fact, it does. And so that's why we are going to block. I'll pause here and see if there's any questions. A lot of subtle things going on here. This is something that you'll definitely want to make sure that you just read through this page before the quiz to understand all of these different subtle things so that you know what to check on the quiz. But any questions at this point that people have? Okay, so it's for no key update in both lines. Because it has a prediction right here of blocking, we'll come over here. I will run line 8 now. Update T set A equals 7, where A equals 1, semicolon, enter, and we can see that it does, in fact, block right here. And so that's why we circled line 8 over here. Again, I'm going to I said this a bunch today, but I'll say it again. On the quiz, you are not allowed to just check the problem, run it like this inside of Postgres. You're not allowed to just run this command and see what happens. You have to be working through this documentation in order to see that these predict what are the locks that will be acquired, and then use these tables to determine whether those will result in blocking actions or non-blocking actions. Okay, problem 33. Again, another subtlety about problem 33 is, so after we've determined that we're going to block on line 8, on line 9 we have this commit action that is happening on the same session as the blocked command. So what do we do there? What we do is we just type commit over here. This is equivalent to just typing commit on this session over here, hitting enter. And line 9, the command that got entered on line 9, it does not run at this point. Instead, we say that it is queued up to run so that as soon as line 8 becomes unblocked, then line 9 will instantly run before any other commands have a chance to run. And so this commit command right here on line 9 has not yet run. It is queued up to run. It is waiting to run until this line right here gets unblocked because of this transaction up here ending, either with an abort or a commit. In this case, in problem 33, we have a commit on line 10. And so if I do commit right here and hit enter, instantly this update 1 will be visible to all other transactions. In particular, it'll be visible to this transaction right here. We will then see that this where clause is not going to select the same row because this row no longer has A equal to 1. It now has A equal to 6. And so this update right here will not update anything, and the commit will be equivalent to an abort. On the top right, I will hit enter, and we'll see in the bottom right that stuff instantly happening as soon as I hit enter up here. So hit enter in the top right, and we can see that immediately this update 0 here, this is the output of this command up here. Again, the number after the update is the number of rows that were updated. And I did not type this commit right here. Instead, this commit over here was that I typed in previously caused that command to be queued up, waiting to run in the future. And so this was automatically run for me instantly when this command up here, when this command right here ran and released the lock created by this command up here. This command was instantly run for me and committing the results of this command, which happened in this case to be nothing. This problem is not explicitly asking for some sort of select here, but for debugging purposes, I will go ahead and run the select star from T right here and hit enter, and we can see that now this update did not in fact run on anything because there is no value with a equal to 7. We only have 2, 3, and 6. Most of this, again, reminding us what we did last week, except we also added in this discussion about how to actually find whether the row level things will lock or not lock, or will block or not block based on the row level locks. Yes?
So you said that line 9 becomes the equivalent of an abort, but it seems like you just updated nothing and did that like the equivalent of just aborting something.
Yeah, so I made a comment about line 9 over here. If we change this to an abort, it would get the exact same results. And the question is, why is that? And the answer is because this update happens to affect 0 rows. And so nothing in this transaction affected any rows. Nothing changed the database in any way. It wouldn't matter whether I committed or aborted or rolled back that transaction. We'd have the exact same effect to the database. So I think that's the same as your summary overall, but did that answer the question?
Yeah, but like under the hood, we're still committing something. Like Postgres isn't aborting under the hood, it's still just committing.
So it's still going through the commit process of what it would commit. There's no visible changes, though. You would not have any way as a user of the database to know whether it was committed or aborted because it doesn't affect anything visible to the user. Okay, there's a number of other problems down here related to these row level locks, and in particular, you have some different commands on different locations. Now, updates and deletes, how are those going to block each other, or updates versus selects? Will those block each other or not block each other? You also have to pay attention to what rows those different locks are being acquired on, and so lots of very subtle things to keep track of here. These row level locks, very easy way to miss points on the quiz because of missing something subtle. So recommend paying close attention in your studying to this section 7, row level locks. Back over here on our notes, there's one last link right here, reference link, that we'll talk about that we haven't talked about yet. And this is going to be a tool that will be useful for you to understand the row level locks, what's going on, so you can sort of check your thought process as you are preparing for the quiz. But again, you will not be able to use, so there's a query down here which will tell you what rows are locked and what rows are not locked. This is useful for preparing for the quiz, but you will not be able to run this query on the quiz itself. In order to see what this query does, I'm going to come back over to our terminal windows over here. I'll create a transaction, begin, and I'll press up arrow, up arrow, up arrow, change, create this update t set a equals 6 where a equals 2 command like this. And now we're going to run that query and see what sort of row level locks we currently have available to us, or what row level locks currently exist with this query over here. So I'll just copy and paste this query right over here. I'll do it in the bottom right window. So I'll do it in the top right window first and hit enter. Uh-oh. You'll see that I get this error message when I first copy and paste this, this command. It says arrow function pg row locks does not exist. And the reason for that is that this command right here, which is needed to run this overall query, is part of something called an extension in Postgres. These are things that are sort of not directly built into Postgres, but user-written libraries, kind of like imports in Python. So like create extension is sort of like imports in Python, just adding a library to your database of new tools that you're allowed to use. And this PG row locks extension has this function for us, which will help us determine what rows are locked. So first, in order to run this debug command up here, I have to create the extension. Doesn't matter where I create that extension at, except I cannot be inside of an aborted transaction. Something that we haven't seen yet is that if you're inside of a transaction and you have a command that fails, that will automatically abort the transaction for you. So here, up here, this command right here failed because this function did not exist. And so now it's telling me I'm currently in an aborted transaction, so I can't run this command right here. So I will manually get out of this transaction, up arrow, rerun my create extension PG row locks. I'm not in an aborted transaction anymore, so it works. Enter my transaction, up arrow, up arrow, up arrow, up arrow, up arrow to get to my update T command like this. And now I can come back over here, copy and paste this command into the top right window over here in order to see what are the locked rows. Oh, and so there's not giving me any. Here we go. In the bottom, so because in the top right window up here, it's this is the row. This is the session that created the lock. The command is not able to see the locks at that point, but in the bottom right session, this is not the session that created the lock. So here we are able to see the lock, and I'll zoom out just a little bit so it fits on one line here. We can see that here the A value of 2. In my update command right here, update set where A equals to 2. So this shows me what the actual value of that particular row was to help me understand why, which row it is that was locked. And then over here, we can see the no key update mode for that particular row. So if you have a question about whether one of the, like which one of these commands, what rows is it actually blocking and what are the block modes, then this, this command right here, it will tell you the answer to that. It'll tell you what the values over here, what the rows are that are currently locked and the current modes that they are locked inside of. Any questions about that debug command? See, not a whole lot of questions going on today. Is that because everything is super easy and everybody's fully understanding everything? Everybody's just not awake yet. Things are glossing in front of everybody's eyes. Question?
Is no key update the same as for no key update?
Oh yeah, good question over here. So on the documentation, here it said, for no key update, because all of these lock modes have just the word for inside of them. The mode over here in this table omitted that for brevity's purposes, and so yes, for no key update in the documentation, equivalent to no key update over here in the output of the command. Good question. There's a bunch of other information in these, in the output of this table. These are things that are definitely useful if you understand what they are for debugging, and the documentation again goes over them, but you're not required to know what they are at this point for the purposes of the quiz. Any other questions at this point? Okay, then that's everything we're going to talk about on this section 7, implicit locks, and we'll scroll down a bunch, skipping a bunch of problems here, lots of problems. So since there's lots of problems, good chance that there'll be something from that section on the quiz, and historically it's been a hard one. They're all hard ones, but a particularly hard one that lots of students miss points on. But now we're going on to section 8 over here, more implicit locks with the unique constraints. Okay, so in order to run this, the code for, we'll start with problem 43 over here. I will just abort any transactions that I might happen to be in, drop table T, and now we are in a clean state and able to start problem 43. The main difference again in problem 43 compared to the previous ones is that we'll be using this unique constraint on our table, on our column over here. And we'll see how that affects our problem. So if I do a create table T a int unique spelled correctly, I think that's spelled correctly, hit enter, that was line 1. Again, the only difference between our create table command this time and our previous ones is I've added this word unique, which will enforce that our column here is unique. And now let's begin our transaction, line 2, line 3. Inside of the transaction, we'll insert into T values 5 like this, semicolon, and hit enter. On the bottom right terminal in session 2, I will do a begin over here and then insert into T values 6 like this, semicolon. And now we have to predict, before I hit enter over here, we'll be computer scientists. Again, scientists run experiments and we follow the scientific method. We generate a hypothesis, test that hypothesis with an experiment, and then update our knowledge of the world based on that hypothesis. In this case, if we, in order to see whether two insert commands are going to block each other, first we'd have to look at the table level locks. But one of the nice things about Postgres is that by default, any of these data modification commands will not block at the table level. And so the insert commands will not block at the table level. Selects, inserts, updates, deletes never will block at the table level if those are the only commands that are going on. At the row level, these might potentially block, but again, insert here, they're going to be happening on probably totally different rows. What might cause a block here is that if we were inserting the same value because of this unique constraint up here. Here on line 3, we've already added a 5 to the database. Line 5 over here, we're adding a 6, different values, and so it's not going to affect this unique constraint at all. And in the bottom right-hand corner, when I hit enter, because the values are unique, we will not block. I'll hit enter, and you can see that we do not block. And so in the top right now, when I do commit, hit enter, bottom right now, do commit and hit enter, nothing blocks. So the correct answer for the quiz on a problem like this would be to make no annotations anywhere. Are there any questions about 43? Yes. Yeah, so the question is that session 2 over here it should be isolated from session 1, and so how does session 2 know whether whether this value over here is the same or different than one of the values over here, and know whether to block or not block? The answer is that there are appropriate locks created on the table and on this unique constraint, which would cause this to block only if this was a 5 inside of here. So at the and so this is maybe this idea of isolation is maybe a little bit of a leaky abstraction, because if you're considering like run times and whether things block or not block, you are able to detect what goes on inside of other transactions. By checking whether things are going to block or not block. But in terms of like what the actual value is that gets returned by a command, so in an insert case, in terms of whether it's going to be like an insert 1 or an insert 0, whether we are actually going to insert things, or in a select, what the result of those selects are. In terms of the return value of commands, those are isolated from each other. But in terms of the runtime of commands, and especially in terms of the locking of commands and blocking of commands, those are not isolated from each other. If the runtime were isolated from each other, then we would have to just block no matter what, because we could never know like whether there's going to be any sort of conflict. So hopefully that helps answer that question a little bit, but yes, good question. I'm going to redo problem 43 here now with just changing these values around so that we will see what happens. And I don't think I have a printout, or yeah, we're basically staying on problem 43 right here, not going on to the next problem. So I will drop table T, Control R, rerun my create table T command, begin, insert into T values 5 like this, line 4, begin. And now the difference here about what I want to do on this problem is that instead of doing an insert into T value 6 right here on line 5, instead of doing it exactly how it's written with a 6 right here, I want to insert into T values 5, and we'll see what happens. In this case, our value up here that we're inserting is already 5. And so on line 5 over here, when we insert 5 instead of 6, when I insert a 5 over here, whether we are going to conflict with the unique constraint will depend on whether line 3 actually gets inserted or not gets inserted. So in the bottom right-hand corner, I'll hit enter, and you can see that we do in fact block because we don't know what the output, what the answer of this is going to be, what the return value of this is going to be, until we know whether this line up here gets committed or aborted. If I commit this line up here, then this value 5 will be available down here to this, this session, and this will generate an error. If I don't commit, if I abort, then this value 5 will not be available, and this will be okay. So in the top right corner, if I type commit, semicolon, hit enter, then you can see we get an error down here. The error says duplicate key value violates the unique constraint, and detail this key already exists. So we get an error in that situation, but if I had aborted, then we would not get an error. Again, for the purposes of the quiz, in terms of annotations, if you do get an error on a command, the unique constraints is the first thing that we've seen that is likely to cause you to get an error. Then you write an X through the commands that cause that error. So down here, problem 43, where did it go? Problem 43, as it's written, we would put nothing because there's a 6 right here, but if there was a 5 right here, then this command both blocked and caused an error, so I would circle it and put an X through it because it first blocked and then caused an error. Any questions about that? Question?
Would you put it, you put the error underneath 5, which would be 7?
So this is a good question. The question is, where exactly, here we see that there's an error happening right here. And so let me, tablet is, my cursor. Get my tablet connected. Uh-oh. What just happened? Did it undo whatever just happened? Oh dear, what is that? Line. Problem 43, that's the one we were on. And we were doing it as if this value is a 5 instead of a 6. And the first time that we went through this, we said this is going to block because the 5 over here blocks with this 5 over here. And then as soon as I run line 6, so again, this value, this command right here was blocked until I ran line 6. And immediately when I ran line 6, this line 5 realized that not only did it block, it was going to error as well. So the error happens on line 5 right here, that it both blocks and errors like this. Line 6, we commit it, And even though the commit caused line 5 over here to error, this commit right here caused this command right here to error. This is the command that errored. And you notice that I haven't even gotten to step 7 yet over here. I've never run a commit over here in the bottom right corner. And so we haven't even gotten to line 7. That can't possibly be the thing that had the error yet. I'm going to walk through this command, this session, so that we can see some of those as it happens to make sure that we're all on the same page here. So I've dropped my table out of the transactions in the top right corner. I will recreate my table a int unique begin semicolon insert into t values 5 semicolon bottom right corner over here begin semicolon insert into t values 5, again, based on your predictions of knowing what is going to happen in the world, not by running the Postgres, but just by reading the documentation and the problem statement up here. You observe that the 5 will conflict with this 5 over here. And so you'll just at line 5, you know that you're going to block, and you add the circle to the problem right here. And then when you get whether this blocks or whether this will error or not error will depend on line 6, whether we are committing or whether we are aborting. Because I'm committing right here, as soon as in the top right corner, I type commit, semicolon, hit enter, that is going to not error on this line. There's nothing wrong with this line, nothing wrong with this session over here. This commit will not error, but this commit will cause this over here to error, this command over here that it's currently blocked. It will release the lock that is causing this command to block, and that will allow this command to actually run. When this command runs, it will see that the 5 already exists and cause the error. So in the top right corner, I'll hit enter, commit, and we can see instantly the error happens down here in the bottom right corner. So line 5 over here, both blocked and errored. Good question. Yes. Fantastic question. The question is here, what is the actual lock that is being acquired that prevents this unique constraint, or that allows this unique constraint to happen? The answer is that it is a lock on something that you are not responsible for. So in Postgres, there's about 20 different types of locks on different types of objects. You are only responsible for the table and row level locks. This is a constraint level lock, or a lock on this unique, sometimes called a unique index, a lock on the unique index. If you look through the documentation, that is where you would find the explanation about this. The details of that locking are not helpful for us, and so I'm not requiring that you understand that in detail. The only way, though, that this lock comes up in practice is, at least for the purposes of our class, is that you're inserting something on a unique constraint where there's this sort of overlap of values. And so you can just rely on your intuition about what a unique constraint is, that these 5s, you can't have them both, and that will solve the problem. If you are interested in the details, looking in the documentation for the unique constraint will explain all of the gory details, but they're not necessary for the quiz. Did that answer your question? Yes, Khadija.
Also, to clarify, when you say constraint, there will also an equal update, not cause the for update or update.
Yeah, this is a great question. So the question is, how does this unique constraint affect row level locks? And so we talked about previously with the update command that there's this for no key update, which is the default of an update command. But if the update command was on a row that contained a unique constraint, then you will be on this for update lock on the row level instead of the for no key update lock. So you are responsible for that knowledge, that if there is a unique constraint here, that will affect the behavior potentially of an update command and how it blocks things. But that is not related to the actual unique constraint itself. And this this particular problem, there are no update commands, and so it doesn't come up. Did that answer your question? Say it again. Yes, an update command on the unique constraint will cause the for update lock instead of the for update no key lock. Yes. The question is it okay to put an error on line 6? And the answer is no, that line 6 is not erroring. It is line 5, in fact, that it is erroring. So putting the circle and the X both on line 5 is what you would have to do. Okay, so it would be okay if you, like, I guess it doesn't matter where the circle and the X are on the line, so something like this would also be acceptable, but they have to be associated with this line 5. That is the thing that is erroring. Line 6, this commit, whether it's on either session side, those are not erroring. It is line 5, this insert command, that is in fact erroring. Good question. Okay, lots more examples of unique constraints over here. Something that will definitely come up on your on the quiz and on your next homework assignment is the idea of deadlocks for related to unique constraints. And the deadlocks can happen when you have multiple tables related to unique constraints. A deadlock can happen when you have multiple tables, both with unique constraints where there's a combination of inserts happening on multiple sides. So pay close attention to the unique constraints and deadlocks on the quiz. Essentially guaranteed that you'll have a problem on that. Line 9, isolation levels 2 with the row level. There's another very subtle thing right here. So I want us to make sure that we spend some good amount of time on section 9 here, and we'll go over problem 49 right now. In the top right command section over here, make sure we're not in any sessions by aborting, and then I will make sure to drop my table T. And so we're in a new session over here, and we can start problem 49. I'll do a create table T, a int, no unique constraints on this problem. So that is going to simplify things for us. You should be happy when there are no unique constraints. It makes things much easier to reason about. Line 2, insert into T values 9, insert into T lowercase values 9, semicolon. Line 3, up arrow, change that 9 to a 10, semicolon. Now I'll run lines 1, 2, and 3. I'm on line 4. I begin my transaction in session 1 in the top right corner. Line 5, I begin my transaction in the bottom right corner. Hit enter. Line 6. We're now in the update and delete clauses. So thinking more about these row level locks and how they are going to interact with each other in terms of a little bit more complicated situation. Also here, as an aside, on line 49, problem 49 and 50, I have a typo right now where line 9 happens at the same time on both sessions. This is a typo on the quiz, and in real life, you can never have two commands happening at the exact same time. This was intended to be on line 10. So that select statement should be on line 10. Similarly, that select statement right here should be on line 10 after line 9, after the transaction on the left-hand side happens. Okay, so I've run commands 1 through 5 now. I'm on command 6, update T, set A equals 1. Update T, set A equals A plus 1, semicolon, hit enter. And we've talked now about how this creates on the table level, the row exclusive lock. And at the table level, these updates, deletes, inserts, all of those commands in Postgres will never block at the table level. And so line 7 over here, it can't possibly block at the table level, but it might block at the row level. I'll run, so in this case, we'll just rely a little bit on our intuition and not look at well, maybe we got the command over here, so let's come over here. Let's just rerun our, I typed.
equals 1.
Oh, thank you. So I have a typo up here on this update T, set A equals 1 plus 1 is what I wrote. This 1 right here should be an A. So in order to fix this, I will just abort this transaction, semicolon, re-enter this transaction, begin, and rerun that update command, update T, set A equals A plus 1, semicolon. Now that is the right command right here, the correct command. And we're now at the consistent state where we should be for line 6. So thank you. Again, I had a typo where I originally put 1 plus 1, but it should have been A plus 1 to match the problem over here. And we've run all the lines from 1 to 6. We're on line 7 trying to figure out what this is going to do. And in order to figure out what line 7 is going to do, I want to see what rows currently have a row level block on them, a row level lock on them. So I'll come back over here, find my row level lock command, copy and paste this over into the bottom right terminal over here, run that, hit enter. Try to make it a little bit easier to read without getting too small font over here. But we can see that there are 2 rows that are blocked currently, 2 rows that have locks on them. 9 and 10. So this update command over here has no where clause. Line 6 over here has no where clause associated with it. So it applies to every row in the table. And in this case, there are 2 rows in the table, 9 and 10. And so when I run this delete from T where A equals 10, this does have a where clause. It is only going to look at the row 10 right here, and it won't care about 9 up here. In this case, row 10 has a no key update, and the delete will also create a no key update lock. And we saw before that those 2 types of row level locks are incompatible with each other. So my prediction is on line 7 right here, when I run this command, delete from T, where A equals 10. My prediction is when I run this command, it is going to block. And I hit enter, and we can see that it does in fact block because of the row level lock created on line 6. Line 8 over here, we have a commit. Again, the commit is happening while this command is still blocked. So it's like I just type it in over here in the terminal, hit enter, and it doesn't run yet. It is queued up to run. It is waiting its turn to run. After this command is, the block is released, then this command will run automatically for us instantly. Line 9 over here, the top right corner, I will commit, semicolon, and hit enter. And that, again, instantly releases this block down here. So let's make sure that I've annotated that correctly with the block up here in line 7. Now, what's different about this set of problems is what this select statement is going to do. And again, this select statement is happening on line 10, intended to happen on line 10, not at the same time as this commit. I see the questions. I will get to them in just a second. Line 10 over here happening after the commit, this select count star from T. And we want to know what is going to happen with this select count star from T. And in particular, we have to predict whether this delete command up here, whether it deleted anything or not deleted anything. And in fact, we can see right here from the output down here of this delete from T where A equals 10 that it did not delete anything. And we know that because there's a 0 here, and this is the total number of rows that were deleted. If I do a select star, so run the command select count star from T, semicolon, hit enter, we can see that there are in fact 2 rows. So there are in fact still 2 rows up here, the 9 and the 10, and so the delete command did not do anything. I'll press the up arrow over here, change this select count star to a count star to debug stuff for us and think about why is it weird that the delete command did not do anything. I hit enter, and here we can see that there is in fact a row of where A equals 10, and there is in fact a row where A equals 11. And so when this line 7 over here, when it got ran, it seems like there should be a row that matched this where A equals 10 condition, this condition right here. It seems like this row should have matched this where A equals 10 condition, and it should have gotten deleted. But it in fact did not get deleted, and so the output of this select statement again should be 2. And the question is, why did it not get deleted? The answer is that anytime you have a a command that is going to update the database, whether it's a delete or an update command. Any delete or update command, you can think of it as being broken up into two parts. So delete or update as two parts. The first part, and I should have written that up here, the part one is doing a select, which selects the appropriate rows. And then part two is actually doing the modifications. Whatever those modifications might be, in this case deleting, or could be updating if it was an updating command. So doing, I'll say doing CMD for short for doing the command. And in this case, the select over here is not going to block. The select up here happens totally normally. The select up here happens totally normally, and it selects the rows that match this condition at step one. At time 7, before this commit happens down over here in the bottom session 1 on line 9, before this commit happens right here, the values in our table are 9 and 10. We have a 9 and a 10 right here. The delete from T where A equals 10, the select where A equals 10 only selects this second row down here. Only selects this second row down here. Does not select this first row up here. And so line 7 down here is only going to consider this second row, only going to consider the spot where it currently has a value that matches this condition. Then after the lock is released, it's going to redo that, recheck that condition to see if that condition still holds. After this commit happens down here, after this commit happens, this 10 is now an 11. So we have an 11, this condition does not match, and so the delete does not go through. And so it matches, the delete matches at the very beginning in the first select clause, and so that's why it blocks, but it does not match when it does the doing command stuff, and so it doesn't actually delete anything. And so we get 2 as the end result down here. I'm going to go and do problem 50 now, see a slightly different situation, and then I'll get back to all the questions that people have. So the difference between problem 50 and 49 is that in problem 50, we have an abort on line 9, whereas in problem 49, we have a commit. And we're going to see how that makes things different in this situation. In order to reset the problem, I will abort, make sure I'm not inside of any transactions, drop my table T, drop table T, and then restart with create table T A int. Create table T A int, semicolon, insert into T, values 9, semicolon, up arrow, values 10. Begin, this is line 4 that I'm on. Line 5, begin down here. Line 6, update T, set A equals A plus 1. No typos this time. It is, in fact, A equals A plus 1. Hit enter, that's line 6. Line 7, everything is the same so far. Delete from T where A equals 10, semicolon. I predict this is going to block. We saw that it previously blocked because of the row level lock that exists only on this row right here, only on the values 10. There is a row level lock on both of these, but the select portion of this delete command only finds this second row for us because that's the only one that matches this condition down here where A equals 10. So I'll hit enter. It does in fact block. Line 8 is the commit, which happens immediately after the block is released. Immediately after this command is allowed to run, this command will also run. That is line 8. We're now on line 9, and this is the only thing that's different about problem 50 and 49 is line 9. In problem 50, we have an abort down here on line 9 versus a commit. So this change over here is not going to take effect. When this change does not take effect, it means the row 10 over here is going to stay as a 10 and not get changed into an 11. And so this delete over here, the rows that are matching by this A equal to 10 will be the same. The very first time we ran this command, when we decided whether we're going to block or not block, it was this line right here, this row right here that we were thinking about, that we selected with this where A equals 10 clause, only the second row that got selected. And now when we go into the second phase of actually doing the delete here, this will still have a 10 inside of it, and so we will actually perform the delete on that row. In the top right corner, we'll observe that happens. I type abort semicolon. As soon as I hit enter, we'll see in the bottom right corner that the block will be released, the lock will be released, and the blocking command will be allowed to run. And we will see that it will in fact delete something, and then the commit will happen. So top right, I hit enter, abort happens. Down here in the bottom right, the delete command down here, we can see there is now in fact a 1 after the delete because we did in fact delete something. And now the commit over here, we've registered that command as something that does happen. And now the final command over here, select count star from T in the bottom right corner, select count star from T, semicolon, hit enter, and we now only get a 1 instead of a 2. Okay, said a lot of things. I'll take a breath now and answer questions. Henry.
So 2 questions. The first one is you said that the order key update. It seems like the documentation says the for update lock mode is required by any key.
Then I misspoke if I said that it was so up here deletes. Yeah, so the delete command right here requiring the for update. Yes, acquired on any delete on a row. So I misspoke if I said this, that the delete should acquire the for update according to the documentation. Yes.
And then the other question is, if we were to have 2 commands in a row that would block, that would block, would we circle both of them, or would we just circle the one that actually starts the block?
So your question is, let's say if we modified problem 49, so there was a delete from t where equals 10 on line 7, and then immediately after that there was another delete from t where equals 10. So both of those 2 things are, if they were both running simultaneously, they would both block because of this update command. Do you circle both of them? The answer is, the general procedure of the way to think about this is that any subsequent command on the right-hand side over here does not immediately get run. It just gets queued up to be run in the future. And so you would only circle subsequent things if they would block after this commit over here has released the block over here. And so in the particular example I gave of repeat line 7 twice, you would only circle the first version of line 7. The second version of line 7 would not do anything, but it would also not block. Yep. Because, yes?
I'm still kind of confused. Why is it?
Yeah, question is, why did it not delete in 49? And if you're confused about that, that's very reasonable to be confused about because it is extremely confusing. The documentation actually goes through that particular example. I pulled that code out of the documentation for, I believe, explicit locking, possibly this. One of these 2 things, one of these 2 links over here walks through in detail that situation and why that is happening. And so I recommend reading through both of them, but you can find that section in these 2 links right here, and it'll walk through in the gory details so you can make sure that you fully understand that. But definitely a very confusing thing. Definitely something that you should expect is somehow going to be on the quiz, and so pay attention to that. I want to make sure that, so we only have 5-ish minutes left. I want to make sure that I cover the highlights of the next sessions down here. So I'm going to talk about those things, and I realize there's a handful of questions still outstanding. I'll make sure to have time after class to answer those. So the remainder of this isolation levels section that's talking about how this interacts with the different isolation levels. This is the important part of this section. So if it seemed confusing before, it's going to be even more confusing once you add the different isolation levels to things. You'll, in particular, get some situations where you both block and error on the same command because of the isolation levels, and you'll need to be able to predict that. So one of these will be both blocking and erroring. One of these will be only blocking. And again, this exact example is coming from the documentation, so you can read through the documentation to get a detailed explanation there. Foreign keys. this section very similar to the unique keys section above. So again, recall that this references keyword makes a foreign key, and every foreign key also has to reference something that has a unique key. So here, our column B references T of A. T of A has a unique key on it. And the unique keys, again, likely to cause problems in different ways, especially with deadlocks. Working through these problems, you'll see what's going to cause a deadlock or what's going to cause blocking based on the foreign keys here. Scrolling down, one last section I think that's important for us, this deferring constraints. We'll do an example of the deferring constraints here. So we'll take a look here at problem 61. Let's abort and abort. Make sure I'm not in a transaction in either of these windows. In the top right window here, we actually only have one session going on. We'll see what's going to happen with the one section. Line 1 through 4, all the same command, again, just broken up into multiple lines because it is for space reasons. And so here, create table T. I will, just to emphasize that this is all one command, write it on one line up here. So far, we've seen the unique keyword after the type of the column. Here's the column name. The new thing about this is we have this deferrable, initially deferred line. Deferrable, initially deferred, D-E-F-E-R-R-A-B-L-E. I always make a typo here, so I'm being very carefully typing in that without any typos. Hit enter. Relation T already exists. I forgot to drop table T, semicolon, up arrow, create table T with that particular constraint here. Int unique deferrable, initially deferred, creates the table. Line 5 will begin our transaction. Begin our transaction in the top right corner. Line 6, insert into T values 8. Insert into T values 8, semicolon. And line 7, based on the fact that we had a unique constraint, it looks like line 7 should error because we have two 8s right here. Insert into T values 8. It looks like this line should error. But when I hit enter, we'll see that it does not, in fact, error, and we actually get this insert happen in both situations. That is because of this deferrable, initially deferred line right up here. What this line says is that we are not going to check this constraint. We're not going to check the unique constraint until after the entire transaction is committed, and then we will check all of the constraints all at once on line 8 on the commit. And so even though this looks like this line should error, line 7 does not in fact error. I do commit here on line 8, and it is line 8 that causes the error, duplicate key violates, blah, blah, blah. And so line 8 is the line that should have the X through it. Line 8, X through it right here, not line 7. If I did not have this deferrable initially deferred right here, if I did not have line 3, then line 7 would be the one that errors. But because I have this deferrable initially deferred, it means that this unique constraint should be checked not immediately, but at the end of the transaction. And it should be line 8 that will error instead of line 7. The rest of this section goes through more examples of this deferrable initially deferred with the unique constraints and the foreign key constraints, and just more examples of things that can happen, deadlocks that would have happened being avoided potentially by having this deferring the constraints until the commit. And then section 12 here at the very end, these are the most complicated problems that combine everything all together into one problem, and you'll have to think about everything all at once in order to solve these problems. Okay, went through all of that last bit of stuff very fast, very reasonable. If you have questions still, I'll stick around after class to get whatever questions answered, but we're out of time now, so that's the end of class for today, and I will see you all on Thursday for the quiz.